Right. Let us discuss some more problems regarding to the resistance and current flowing through a circuit, series and parallel connection. So many different kinds of problems are there. Among them, we will discuss only few. Many different problems, different methods, whatever. So we need to understand the circuit problems. Okay, if it is possible, I will post the some problems in folder as a pictures. I wrote the problem and answer, and I will send you a photos or a pictures for your practice. So due to time constraint, so unable to explain all those problems. So let us understand only one or two. Right. Okay. Let's go to the diagram. The circuit diagram given below. The circuit diagram. The circuit diagram given below. Shows the combination of three resistors R1, R2, R3. R1, R2, R3. Then find three parts. Total resistance of the circuit. Total resistance of the circuit. Then second part, total current. Total current flowing in the circuit. Total current flowing in the circuit. The potential difference. Across R1. The potential difference across R1. So the diagram should be drawn, already given in the problem. So this is R1, R2, R3, 2 and 2. This is the diagram. By observing the diagram, so we have to find the total resistance of the circuit, total current flowing in the circuit, the potential difference across the resistor R1. Potential difference across the R1. Right? So, let us solve. Okay. Observe diagram first. R2 and R3. R2 and R3 are in parallel with R1. With R1. So, first calculate the total resistance of this parallel connection. Then find out the total resistance with R1. So, that is equal to the total resistance of the circuit. Then, after knowing the total resistance of the circuit, then we need to find out the current flowing in the circuit. Then after we can find the potential difference. Right. As usual, let R1 values given 4 ohms, 3 ohms, 6 ohms. Sorry, here the 4 ohms, 3 ohms and 6 ohms. R1 is equal to 4 ohms, R2 is equal to 3 ohms, R3 is equal to 6 ohms. So, let's find out the equivalent resistance. Equivalent resistance of R2 and R3 in parallel. In parallel. So R2 and R3 series resistors are in parallel. So 1 by R parallel. 1 by R parallel is equal to 1 by R2 plus 1 by R2. That is equal to 1 by 3 plus 1 by 6. That is equal to 6 is the LCM, 2 plus 1. So 1 by R EQ or 1 parallel. So 3 by 6. 3 by 6. From this R parallel or R EQ is equal to 6 by 3. That is equal to 2 ohms. So first we find the equivalent resistance of two resistors which are connected in parallel, R2 and R3. So total resistance R eq or R total is equal to, so this is completely series with R1. So you can write R parallel plus R1. R parallel plus R1. So R parallel is 2 ohms, R1 is 4 ohms. So 6 ohms. That is equal to total resistance R total is equal to 6 ohms. R total is equal to 6 ohms. Right? So these after the resistance, the circuit diagram will be drawn as like this. Just for our understanding. So now this is the R1 and this is the REQ or R parallel. So diagram change like this. So instead of using R2 and R3 resistors, if we use a resistor with 2 ohms, with 6 ohms, that should be is connected in a series. With R1 with R1. Instead of these two, we have to use only one resistor that should be connected with series with R1. So then diagram should be written as like this. How we will get? By the combination of this. So we calculated total resistance. Then coming to the second part, total current flowing in the circuit. Total current flowing in the circuit. Potential difference. Potential difference of battery or cell. V is equal to how much? 12 volt. V is equal to 12 volts. Then total resistance. Total resistance. Potential difference, or we can write as simply voltage. Voltage V is equal to total resistance Req is equal to 6 volts. 6 ohms from Ohm's law. From Ohm's law, V is equal to IR. V is equal to IR. So here we can write Req. So I is equal to current I is equal to V by R. Current I is equal to V by R. Substitute V is 12. Then resistance 6 ohms. That is equal to 2 amperes. 2 amperes of current. 2 amperes of current is flowing through the circuit. The total current flowing in the circuit I is equal to 2 amperes. I is equal to 2 amperes. Potential difference of the battery or voltage. Then calculate the potential difference across R1. So every resistor has potential difference. Potential difference. R1 has potential difference. R2 has potential difference. R3 has potential difference. Every resistor has a potential difference. So we can calculate the potential difference across R1. So we need to find only the potential difference of R1. Right. For calculating potential difference R1, so we know R1 resistance is equal to 4 ohms. So resistance. Then current I. How much current is flowing in the circuit? The total current flowing in the circuit is 2 amperes. 2 amperes. So 2 amperes current. So we need to calculate V. Nothing but potential difference. Potential difference. So from Ohm's law. From Ohm's law, V is equal to IR. V is equal to IR. Then we can write VR1, potential difference of resistor R1 is equal to IR1. Is equal to IR1. So R1 is the resistance, I is the current. So that is equal to 2 into 4. 2 into 4. That is equal to 8 volts. So potential difference of resistor R1. Potential difference of resistor R1 is equal to 8 volt. 8 volt. Similarly, we have to calculate the resistance of R2. R3 also. Just for understanding. So if resistor R2. So current resistor R2 is 3 ohms and current I is equal to 2 amperes. So potential difference potential difference across R2. Potential difference across R2. So we can write IR2. We can write IR2. That is equal to 2 into 3. 2 into 3. That is equal to 6 volts. That is equal to 6 volts. So potential difference of R2 is 6 volt. 6 volt. Then we can find out the R3 also. But in case of if the two resistors are connected in a parallel, generally the voltage is same. The voltage is same. For example, the additional I am giving you potential difference across R2. Here potential difference across R3. So R3 is equal to 6 volts. I am usually 2 amperes total current. So V is equal to IR3. So 6 into 2, 12 volts. 6 into 12 volts is additional. So finally we calculated total resistance R total is equal to 6 ohms. The second one, total current I is equal to 2 amperes. Then third one, potential difference across R1 is equal to 8 volts. This is the problem. Circuit diagram is given in the problem. So by analyzing the circuit diagram, then we have to calculate the total resistance, total current, potential difference across it. So I hope you understood, right? Then go for the one more problem. Right. Our next problem. So here I did not explain any problems regarding to government textbook because of in your material all solutions are given. Right. One very few I explain. Remaining I will send you a picture with solutions. Similar problem. Okay, then one more problem. Same, all problems are like that only, right? So then similar problems are there. So many circuit diagrams are there. So I don't want means not I don't want. Instead of that, so I will show you the pictures or photographs. But one important thing. Different ways of combining resistors in parallel and series. In the diagram simply I drawn a different only one type of picture. How do we understand the resistors are connected in series or parallel? So different way the resistors are connected. So in case of parallel, different ways of combining resistors or resistances in parallel. So how do we connect? So one is R1, R2. This is one type of parallel connection. Then R1, R2. This is also a parallel connection. R1, R2. This is also a parallel connection. So resistors see how many times we have to bend, then there is no change in the flow of electrons. So kabatti then however we want, we have to connect like this. Then this is also parallel connection. 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 So the resistors are connected differently in a parallel combination. In case of series, see here R1, R2, R3 are nothing but the electrical appliances. Just all the electrical appliances. Resistors are nothing but electrical appliances such as bulb, fan, refrigerator, heater, TV set, whatever. Right? Then in series, so R1, R2. This is also series. This is also a series. R1, R2. This is also series. Plus minus. R1, R2, R2. So this is the series connections. Series connections. Different ways we have to combine the resistors. Parallel, these many ways. Then series, these many ways. Why I am going here? In case if any circuit based diagrams or circuit based problems are given in the examination, to understand is it parallel combination or series combination, right? So this is about the problems. Many problems are there, so no time is sufficient to explain all the problems. So I have to send a pictures the problems like this. So the problem and the solution. The problem and the solution. So I will make a video for the problems, and I will send it. I will post pictures of all the problems which are I practiced from various publishers, from the government textbook problems, from private publishers problems, everything, every problem. So I will send you as pictures in the post. If it is possible, I will make a video of all the solutions. Thank you.